Hello everyone and welcome back to the topic 4.1, which is waves. For today, we're going to discuss about phase difference. But in order for us to discuss about phase difference, we need to understand what is the phase. A phase is an angle at which the wave motion started. We can specify it as the location of a point within a wave cycle of a repetitive form. So we can see here that this one is a wavelength from here to this point to this point. So we're talking about points here. You will notice that there is an angle also related onto this circle. And you might be thinking, what is the relationship of this wave to a circle? Let's have a quick simulation onto this, on what I am saying. Imagine that you have a point here. A point is moving in a circular motion. Before we talk about this difference, we need to make an observation about the shape of a wave. Any wave can be understood as the graph of a vertical height of the radius line of a circle on the y-axis and the angle of the vector on the x-axis. As the circle goes around, you'll notice that if we track just the vertical height of that radius line, as it goes around the circle, that produces a wave. This is just the same as this one, as this is also exhibiting a simple harmonic motion. You will notice that this circle is having one complete cycle. And you know that one complete cycle is equal to 360 degrees. This also up and down motion, which exhibiting a simple harmonic motion, is also having one cycle. And one cycle is 2 pi rad. And 2 pi rad, as you know, is also equal to 360 degrees. So we can have a bold statement that uniform circular motion of a particle can be viewed as simple harmonic motion. And we're going to proceed. Here we have phase. Again, we're talking about points in a wave. This point is 0 degrees. However, if this is gonna be moving here, this is out of phase. Compared to this one, compared to the first wave, to this one, this is out of phase because this one is at 180 degrees. You can see here that the crest, if we're going to discuss this point, the crest here is now the throw. And you know that one wavelength is equivalent to 360 degrees. So that means that the measurement of this one is half of a wavelength, which is a pi rad or 180 degrees. Now, how about for here? If the point here is here, then that means that this is 90 degrees or pi over 2. If this is here, then that means it's 270 degrees or 3 pi over 2, knowing that the reference here is at this point. So if this point goes here, it's 90 degrees. Okay? If it goes here, then it is 180 degrees. If it goes here, then it is 270 degrees. And if it goes back, it is 360 degrees, or it's also equivalent to 0 degrees for the other wave. Now, we are going to discuss about phase difference. I believe that you already grasp the information that I have already said to you, informed you. So we are going to have this. We know that this circle is also related onto the wave. The points here, for example, the blue wave is also related onto this, and this one is related onto this. So there must be an angle. The difference of the angle here is also what we call the phase difference. Okay? The difference in angles between two waves at a specific point. So how do we solve the phase difference? The phase difference of pi at all points. How can we identify this? We know that this one is at 90 degrees. This one is at 270 degrees, just like in the previous slides. So that means 270 degrees minus 90 degrees is equal to 180 degrees at all points, which is pi rad. You will notice that this particular point is here also. However, they vary depending on the direction. This is out of phase. Okay? So how do we solve this? For example, that we have the red wave, blue wave, and violet wave. By the way, I've already got this in the example in the book. 3 graphs of simple harmonic oscillations with the phase difference between them. So how do we identify the phase difference from the red to blue and from red to violet? So the formula here for the phase difference is the shift over the period times 360 degrees. So we have displacement time graph here. So for example, we know that the period here is 1 second because this is one wavelength. So here we have 0.5. The half of this one is 0.250, and from red to blue, this is 0.125. So we say that the shift is 0.125 all over 1, which is the period, times 360 degrees. That means that the phase difference for this red to blue is 45 degrees, or pi over 4. How about from red to violet? If we're talking about from red to violet, then that means that it is 0.250 over 1 times 360 degrees is equal to 90 degrees, which is also equal to pi over 2 radians. I hope I am clear. I know that this is a new lesson to you. However, you can of course ask me if you're confused and I can create a new video. You can also watch the next videos with exercises. That will be all. Thank you.